you to this exceptional expert talk event where we have the privilege of hosting a distinguished guest, a leading scientist from the Indian Space Research Organization, ISRO, Mr. Piyush Kumar Gaurav. Today, we transcend geographical boundaries and bring you into the fascinating world of machine learning through the virtual realm of Google Meet. As technology continues to advance at an astonishing pace, our ISRO scientists will provide us with invaluable insight for a captivating exploration of the future right from the comfort of your screens. Get ready to delve into the cutting edge domain of machine learning, where the stars align with technology to shape the future of our world. We would like to thank our sponsors, Scholar Personal Tutors, and Pramukh Guru Infotech. I would like to invite our coding club coordinator, who not only worked hard to make this club a platform for such great events to happen, but also helped our students making aware about the importance of learning coding into lives. Please join me in welcoming Shaurya Bhushan to provide us with the additional insights of our distinguished guest and shed more light on the incredible achievements and contributions of youth.
Thank you, Piyush. So first of all, I want to give a warm welcome to Piyush Kumar Gaurav sir. So first of all, thank you Bhaiya for joining us for this event. From childhood, you have been an inspiration for me, and now like I want everyone to be inspired by you and get as much as knowledge as you can. Okay, so let's start with the questions here. Handing over to Sisya.
Thank you, Shaurya and the team for having me here. Even I'm equally excited to be with you and interact with you all, guys. I hope I'm audible, right?
Yes, yes, you are audible.
Yes, you are.
Thank you.
Thank you, sir. I request Srishti, Sharan and Samriddhi to take over and pose questions on behalf of all of you from our guest.
So let's begin with the question, Aya. The first question is, tell us about your captivating career journey from IIST to being a scientist at ISRO.
Okay, so after my 12th, I was preparing for IIT. Unfortunately, I could not get a great rank, so my rank was around 6,000 at that point of time. So it was 2007. I was looking for a good branch and a good college. So in IITs, I was not getting a great branch of my choice. So so there was a college of IIST, Indian Institute of Space Science and Technology, which was opened at the same year. So ISRO was always special to me, like many other undergrad student, 12 students. So I was hoping to get attached to ISRO, and this was one opportunity which I luckily came across and I accepted. And then I joined IST. It was a 4-year journey of a BTech degree. In 2011 I was absorbed in ISRO at URL Satellite Center. I started working as a electrical systems engineer for satellite systems, although my branch was physical sciences. And then I moved upon, and then later on I joined the flight dynamics group, where we do a lot of maths and physics.
Moving to the next question, which we most are eager to know. What is the qualification required for being a scientist in physics? Are there any branch restrictions, or it is open to all?
See, for becoming a scientist or joining ISRO as a scientist, you need to have a BTech or a BE degree. You can even join after your master's degree. So, in fact, ISRO takes care that if you have done masters, you should be eligible for a higher post, right? So, the first promotion happens a bit early. So it helps there. So even if you have done your masters, you can join after that, and then you can even join after your PhD degree. And after your PhD degree, you will join at one post higher. So yeah, a lot of ways. There are actually 2 ways. Either you can join through IST, so you do your BTech and BE degree through IST and get absorbed, or else you can appear through the ICRB examinations. But both requires the similar qualification which I just now told. Now, as per branches, space missions or any kind of space company is quite an interdisciplinary task. So all the major engineering branches will have a role. So no matter you belong to a computer science department, maths, physics, electrical, electronics, mechanical, everybody will get a role, even chemical engineers. If you want to get associated with a space organization, degree most probably will not be a limitation.
Okay. Now, can you please tell us, which we are all eager to know, the insights which you can share deeply about Chandrayaan 1 and Chandrayaan 2? How do they manage such huge projects?
See, Chandrayaan 1 was the first lunar mission launched by us. It was launched in 2008, and in fact, I didn't even join at that point of time. So I joined later on in 2011. But Chandrayaan 1 was having a simpler objective. It was we have never exercised such a mission which goes interplanetary. So we were always orbiting around the Earth previous to that. So the objective was to orbit around the moon. We wanted to map the moon surface and also wanted to map the chemical compositions, or chemical, in short we can say the chemical mapping of moon. So there were lots of payloads which were there on that mission. So like terrain mapping camera, hyperspectral images. So generally the camera which you use, it works in the visible region, right? So it has a very broad range of spectrum in which it works. So you can work in a very narrow range but multiple number of bands. So hyperspectral imager was there, laser ranging instrument were there, infrared cameras, then high energy spectrometer, moon impact probe, synthetic aperture radar. So those were the main objectives. We wanted to orbit around the moon, but we wanted to do some meaningful science experiments. Chandrayaan 2 was a big leap ahead from Chandrayaan 1, because we wanted not only to do some science experiments while orbiting, we also wanted to land on moon, do a soft landing. Then we wanted to have a rover on the surface of the moon. Now, the orbiter is still orbiting around the moon, and in fact, the images which Chandrayaan 2 provides through its orbiter, which is still working, they are actually the best imaging system around the moon. So, in fact, if you compare to our counterparts like NASA, so our imaging system is at least 4 times better in terms of resolution. So, at present, that's the best camera we have around the moon. Then we have the payloads like camera, spectrometer, synthetic aperture radar, all those things. But yeah, we couldn't soft land at that point of time. But nevertheless, this mission was quite important for us. There were many designs which got validated, many improvements and glitches which got identified. So quite a learning experience. And later on, you already know about Chandrayaan 3 that it was very similar in terms of experiments. The only difference I would say is the orbiter this time was not having many science instruments, but it was mainly supposed to do the job of transporting lander and rover to the moon orbit. Right, so lander and rover has very similar kind of instruments. Then we plan to land on the south pole of the moon, so which was kind of unique because not many people have. I mean, in fact, nobody else has done it, and also it was a bit of challenge because sun declination was quite low. So you will see sun mostly at the horizon. So it was near to 9 degree. And so power generation was always a constraint, right? So yeah, I think these were the main captivating features for Chandrayaan 2 and Chandrayaan 3. Chandrayaan 3, I think we are working quite a lot for this complete year. Chandrayaan, in fact, before the launch, I wanted to share one experience. In fact, I've shared this with some other platforms also, that before the launch of Chandrayaan 3, we did many simulations, right? So I think July was the time when it was launched. So even in the by the end of June, we did many experiments. We developed many trajectories towards the moon, and our landing, whenever we wanted to initiate the landing, that landing init part, so which was actually called nav init, navigation init, so that uh, we planned on 23rd August itself, but 5:15 at the 5:15 evening Indian Standard Time, and later on you would have seen that it achieved a time of 5:13. So there was just a difference of 2 minutes. So that is how mature our calculation was in terms of flight dynamics. And yeah, I mean, we had a very well built system this time, and we were very confident even before the launch.
Great applause for that was very
Now, I
interesting
think
to know.
there was a second question on how do we manage these huge projects. Is definitely it's quite huge in terms of the people involved, in terms of the discipline of work involved. So quite an interdisciplinary and collaborative work. But it is important to clearly define the roles of various entities. So there are various experts, various from completely different domain. So it is very important to define all their roles. If you see the project management, we have a hierarchy of posts. So starting from project director to there are several deputy project directors and project managers, each belonging to one of the specialized domain, and everybody will act as a focal point, and then the whole department will make sure that every analysis has been gone through. There should be an extensive testing and simulation. All the redundancy and backup strategies are taken care of. In ISRO, in fact, there is something like very rigorous brainstorming review system which happens. So there are senior peoples who take reviews of our design. So whatever we design, we present in front of them. Several questions we'll have to answer. The design is thoroughly checked, thoroughly questioned. There is a very critical review systems which happen. So yeah, that actually helps. That helps to evolve the system. That helps us to correct it, to find out glitches, and then later on we get prepared for the final mission campaign.
This means we can from which we can extract a great successful mission requires a lot of precision.
Yeah, sure. Yeah, definitely.
Moving to the next question, what's the role and task of a scientist to be performed at ISRO?
See, scientist and engineer can be used interchangeably if we are working in ISRO. So there are many roles. It always depends upon the area of expertise which you are working in. So as I said, there is a very many area of expertise in ISRO. So the basic thing is, as a scientist, you need to perform a research and development, right? So you need to design and innovate some space technologies. It can be spacecraft, launch vehicles, or it can be any associated systems or subsystems, right? So, and scientists are also involved in your mission design, control, and operations. So we plan the whole operations, the whole mission. We design it. We define the mission objectives. If we define the mission objectives, what are the payloads or the scientific instrument that has to go through? What is the trajectory that we have to plan for achieving those missions, especially in those interplanetary missions? Then spacecraft development. So as a scientist and engineer, you need to develop the spacecraft, its subsystems, its payload, not only on paper but also in terms of hardware. So if you see a total spacecraft system, it is composed of many different subsystems. For example, there's something called payload, which is the actual scientific instruments, right? But in order to run the payload, we need various other subsystems like structure of the whole satellite, the thermal systems. These are taken care by the mechanical engineer. Then power systems, control systems, communication systems, and so on, right? And similarly, the same way you have to go on for a launch vehicle development. The development of all the stages of the launch vehicle, you need to integrate them. You need to have engineers from propulsion design has to be finalized, aerodynamics, structural engineering. All this comes together to develop one mission. And once it is launched, you need to have a proper ground station support, right? So once it is satellite is launched, you need to track the satellite, you need to communicate with the satellite, you need to command them, right? So all these things are very important. In fact, even one missing link can be very fatal for a spacecraft design. And all along, you need to have a strict control on testing and quality assurance. And once the satellite is up there on the orbit, it sends the data. We need to analyze the data, interpret the data. So kind of a very diverse amount of role which a scientist plays. It depends upon the background or the stream which it belongs to.
Wow, that was a very complicated structure, sir. So moving to the next question, what was your major contributions in Chandrayaan 1 and 2 and also in Aditya L1 missions of ISRO?
Yeah, so I mean, obviously Chandrayaan 1 I wasn't there, but yeah, Chandrayaan 2, Chandrayaan 3, and Aditya L1 mission. These are the missions I have worked on along with some Earth orbiting satellites. So first of all, I'll tell you what my group does. So I work in flight dynamics group. So we are a group who mainly works in the maths and the physics part. So in physics, especially the astrodynamics part, right? So with a strong flavor of aerospace and computer science, and our role or the our role or contribution is limited to basically three major topics. One is like maneuver planning. So you might have seen those pictures of satellite in an elliptical orbit, right? So, and that elliptical orbit increases further, and then finally you get the trajectory goes to moon and then captures again an elliptical orbit, and there are several elliptical orbits in the moon also. So all these change in orbit happens because there is an engine on board the satellite. With the engine fires and there is a change in the velocity which is observed, right? When you change the velocity, it captures a different orbit. I mean, that's how we do it. And every time we fire the engine, this is called maneuver planning. So we need to plan that maneuver, when to fire, what amount to fire, so that we can go from a smaller elliptical orbit to a larger elliptical orbits. And the parameters of these elliptical orbits are well defined a priori. So these are all designed. So because in a three-dimensional space, you will see an elliptical orbit. But again, the elliptical orbit will have a lot of parameters. What is the size of this? What is there are actually 6 parameters. So all these 6 parameters are defined a priori for all the elliptical orbit. So for this, there's a lot of maneuver planning which goes behind. So we do that. Then we also work on attitude determination, design, and analysis. When I call attitude, that is nothing but the satellite orientation, right? So satellite is a three-dimensional body. So its orientation in space has to be defined, right? So it is defined. You can define that in terms of a 3x3 matrix, right? So just after the launch until the satellite lands, there are various many phases. For each of the phases, what exactly should be the satellite attitude, right? When we have to communicate to the ground, what should be the attitude? When you have to do the maneuver, what should be the attitude? If we are wrong there, we can do a wrong maneuver. So those design, analysis, and even determination is a very important role. Apart from that, once you reach an orbit, how do you determine the orbit, right? So you don't know which orbit satellite is moving around. So we know it because we are getting some range measurements of the satellite on ground. So these are the three major roles. My specific role is limited to maneuver planning. So when to do those firings, how much amount to do those firings, what is the orbit to be attained, what should be the orientation of the satellite. So attitude determination, design and analysis, and the maneuver planning part. So these are the activities which I personally belong to for Chandrayaan 3, Chandrayaan 2, and even this Aditya L1 mission.
That was really great. A huge round of applause for Moving to the next question. What do you think and your experience and analysis over the whole current boom of AI/ML all around the leading to tougher competitions?
No, I think I missed you. Can you come again?
Yeah, sure. What do you think and your experience and analysis over the whole current boom of AI/ML all around leading to a tougher competition?
Yes, see, AI is surely, I mean, we all know it's a transformative technology, right? So it has a lot of potential. It leads, and because of its potential, it leads to a tougher competition. Companies can now automate tasks, it can improve their efficiency, it can even develop some new products and services. uh, right now you see most of the application of AI is in retail industry, I mean, and it is very rapidly entering into various other applications like finance, healthcare, space, everywhere else, right? So I mean, it is now becoming a compulsion. It is now becoming mandatory for all the companies to adopt these AI technologies, otherwise they will be left behind, right? So it involves a lot of competition between those companies, but at the same time these competition, I believe it's not bad, because it also give rise to very new opportunities, right, in the market. So every company has to recruit some AI engineers. I mean, that way I feel there's a lot of positive also happening around. So and still I feel that the field of AI is at a primitive stage. There is a lot to happen, a lot will happen. You see the rise of chatbots, right? So it was not heard before earlier. I mean, there were no chatbots earlier. As soon as AI has come in, there is a lot of AI powered chatbots, AI powered medical diagnostics. So these are many new areas which are coming up, and I believe there will be a lot of requirement. You see, there are governments are spending a lot on AI research these days. So you can expect these there will be a tougher competition, but still the opportunities will also increase.
Okay, so I would like to ask about all the sources you would like to prefer to start the journey of AI and ML.
Yes, in fact, I wanted to speak about it. Right now, the situation is you have too many resources, and you need to select which one is actually relevant for you, right? So people can actually waste a lot of time in going through plenty of video lectures, plenty of YouTube lectures, which might not give you, or which might give you a very delta improvement, which is definitely not so preferred, right? So it's important to go through very reputed online courses, for example, that from Stanford, MIT, and we are in a fortunate time that all these things are openly available, right? Even from IITs. So it's important to like I've seen the courses from Andrew and NG. So they're really good courses, very high quality courses. Apart from that, it's also important to not leave behind the books, right? So there are very good books like pattern recognition and machine learning, right? You might be all aware of, in fact, Bishop by Christopher Bishop, Deep Learning by Goodfellow. There's a very new book of Understanding Deep Learning by Simon. A very technical, probabilistic view of machine learning by Kevin Murphy. So they're all very, I mean, select your books, very important. And then don't forget to have a good hold on maths and statistics. Uh, Understanding the mathematical depth of any algorithm is much more important than using just a few libraries and getting the job done. So because in real life, when you come across some issue, you need to debug, you need to build a better model. It's the mathematical depth of the algorithm which will help you, not those libraries, right? So try to code those algorithms from scratch without using any built-in libraries. So for example, you can use NumPy and then code everything, right? So that will give you a lot of understanding. Obviously, you can participate in many of the coding competitions like Kaggle. There are many other platforms also. You can collaborate with other AI ML community. But yeah, once again, be very selective. Don't waste your time on YouTube video, because there are many videos which will just use some libraries, get your job done in terms of regression or deep implementation of a deep learning. Go behind it. Go learn the mathematical insights, go to the basics. Obviously, there is no shortcut. You need to spend time. understanding concepts and coding will take some time, but that's just fine. That's just fine.
Definitely our audience will know that. Moving to the next question. Which section of AIML is playing major role in space and technology?
Actually, AIML is generally used in a very, I mean, before AIML also people used to launch satellites, right? So, right now the role of AIML is to very sophisticated space missions. In fact, in future it will definitely increase a lot. Uh, for example, there are you I mean, in space, you might want to do some autonomous operations, right? So, for example, there is a satellite already orbiting around. You want to send another satellite, want to dock it, then or and do some satellite servicing, maintenance, refueling operations. So, and in order to perform those things, you might want to have a robotic arm. So that robotic arm or tools for some servicing the satellite. So in those technologies, you will require a merger of this AI, ML, and robotics. I mean, there are a lot of companies which are right now doing it, but yeah, I mean, in India, we are at the initial stage at this point of time. Then we have autonomous rover operations, right? If you're doing a planetary exploration, you need to analyze a lot of sensor data, and maybe you have to decide an optimal path to travel across for these rovers, for these rover operations. So those will require a lot of ML algorithms. And presently, if you see, computer vision and data analysis of a satellite imagery is very popular. It's been going on. So, for instance, if you have a satellite observation data, let's say the application can be immense, right? So it can be agricultural application, weather forecasting, disaster management, or urban planning, environmental monitoring. You need to analyze those images. It can be a microwave image, it can be a SAR image, synthetic aperture radar image, or it can be a normal image which you have in your visible region. So those things again require a lot of AI ML based algorithms. Then in terms of space station, there is a lot of other possibilities. For example, humanoid robot, so which mimics human-like movement and interaction. So you can do autonomous navigation, teleoperation, object manipulations, all those things by a well-matured AI algorithms. And then you can also have like voice assistant, right? So right now you may all be using some voice assistant like Alexa, Siri, but how about how about having it in a space station, right? So there are free flyers which can act as a voice assistant to the astronauts, and even an NLP engineer will have a good role in that scenario.
Thank you so
Yeah, I
much.
mean these are the major I think applications which you can have in space for AIML.
Thank you for such an eye-opening answers. Everyone will surely take a note of this. Now, moving onwards, we would like to know the selection process done, basically the procedure to get into this role.
See, basically there are two ways by which you can by which you, if you want, you can go in ISRO. One is my way, which is going through Indian Institute of Space Science and Technology. So you can, after 12th, you can join IST, and there are three branches even now: avionics, aerospace, and physical sciences. Or I think physical sciences have now become applied science, or applied science. Yeah. So you can join IST, and based upon the vacancy at the end of fourth year, you will be absorbed in ISRO. So I mean that's based upon the vacancy and also based upon your performance in those 4 years. So there are some criterias of CGPA and all those things, and then you will be absorbed in any of the ISRO center, whichever has a vacancy and whichever have a relevant work for you. Apart from that, there is another way by which you can appear for the ICRB examination. ICRB is ISRO, uh, uh, I think, recruitment board, some examination. So by which either by after BTech, masters, or PhD program, you can actually appear for the ICRB examination, appear for the interview once you get selected, and then get absorbed in ISRO.
Moving to the next question. Since you graduated at 2011 and did your master's at 2020. So in this time period, what were the things you were focused on or the struggles you faced and what you decided to further doing your PhD in electrical engineering?
Yeah, so okay, yeah, I in BTech I worked in physical sciences, so it was mainly maths, physics, remote sensing, all those things. So I was not so involved in electrical engineering at that point of time. But after graduating, I joined ISRO as an electrical systems engineer, which happened to me. I mean, kind of fortunate or unfortunate, but yeah, it actually was very kind of monumental moment for in my career, because when I joined, there was a lot of new areas which I was supposed to explore, and since engineering, I was very passionate about engineering, so I wanted to explore more. I don't want myself to be limited to only one branch. So I was at that time I was quite okay with the theoretical concepts of engineering, especially in my stream. But there are two things which I was primarily lacking. One was like the practical implications of those engineering concepts. So I studied, for example, I studied eigenvalues, eigenvectors, all those things, right? So, but where do we exactly use them in a practical scenario? Let's say a space environment. Okay, so once I joined ISRO, I got to know many of the applications. For example, I told you about eigenvector, eigenvalue, right? So a spacecraft attitude is modeled using a 3 by 3 attitude matrix, and an eigenvector plays a very important role on which axis you are doing those rotations. So these are very motivating things which I felt at that point of time, and it made me more curious. The second was I always wanted to understand the bigger picture. So I mean, how, because the space missions are so interdisciplinary, I wanted to have a full working of a space mission design, how it works. So that is something which I always wanted. So by 2020, I made myself a bit more prepared. I was in a position that I can take any of the branch. So I can even take electrical, computer science, aerospace, or mechanical. So I was kind of comfortable with all these kinds of major branches. So although I mean I wanted to do masters much early, but the work commitments and all, because of those things, I happened to get a chance in 2020. I got interested to machine learning, and especially the underlying mathematics part, because probability stats kind of attracts me a lot. So electrical engineering at IIT Kanpur has a special stream of control and automation specialization. So it was an ideal balance for me to explore the area of machine learning and its application. Not just going into the theoretical part, but both of it. It was kind of a balance of both. So I mean, that's how my journey from BTech to masters came in 2020.
Okay, so since IT sector faces a lot of layoffs, especially now during the time of recession, does this anyway impact the scientists of this world?
See, being in ISRO, you are a bit fortunate, I think, in this regard. So, in terms of recession life, we are at a bit peaceful and immune at ISRO. So, although in past few years, because of recession, there were hardly any vacancies that were floated for recruitments, but this certainly, and in fact, this has certainly increased the load on the existing scientists. With, I mean, among us, there were a lot of load because not many recruitments were happening. But lately, I came to know that recruitments have started happening like before, and yeah, I mean, in conclusion, I mean, not so. I mean, quite peaceful for us. I mean, not so difficult situation for us. The existing engineers.
Moving to the next question, which we would love to know the answer. How do you maintain your consistency in your work and keep increasing your knowledge now?
See, these things are something which will depend upon individual. Maintaining consistency in your work, I mean, once you join, I think you are all in college right now, so once you join your start doing your job, it will be a very important aspect. I mean, not only in your professional growth, but in fact in your personal life as well, I feel. There are a few strategies which I personally follow. It may differ from other people. For example, I try to set my goals very clear. I mean, I don't jump into something immediately. I try to spend maybe a few days to lay out a plan. I mean, what exactly I have to do, what are the materials I have to use, what should be my path, This kind of helped me to organize myself. I have a long term goal, but I try to break them into short term goals. Try to dedicate some time for the learning as well. I mean, try to read, take some courses, attending workshops. These are continuous things. I always keep some time, which make me always curious and capable to know later on. I also try to follow industry news and trends, development, what's happening around the world, and then a periodical assessment is also I feel quite important because it will help us to identify those areas of improvement. We can even adjust our overall goal strategies. Better to keep some record of whatever you have done, whatever you have achieved, whatever project you have completed, whatever skills you have acquired. I mean, once you note it down, you will get further more motivated to do further, because you know that in last 1 month I've done this much. So obviously, in the next month I can do something very similar. So be consistent. I mean, try to do these things consistently, and at the same time maintain a very good work-life balance. I mean, it will help you to prevent burnout. I mean, include some time for relaxation, with being with friends, celebrating your achievements. All those things are also quite important. uh, at the same time, yeah, you connect and collaborate with other people, other professionals, colleagues, your friends, your mentors, peers. Try to connect with them, collaborate with some projects. I mean, if you do these things consistently, I feel it's quite useful. At least for me, it's quite useful.
Okay. Now, what would be your suggestion as per your experience, and which would be truly valuable for a new beginner into AI MLP and for a student who already enrolled and struggling with projects, or how should he or she must proceed with it?
See, I mean, there's something. I mean, I have already told a bit of it. So it is very important, if you're a beginner or even though you are working in AI ML field, it's very important to understand the basics. I mean, build a very strong foundation in mathematics, particularly like linear algebra, calculus, statistics, probability. These are very essential to understand the AI ML concept, because once you start working in industry, they will expect you not just to run a program or include some library. They would want you, and if you really want to succeed well, they will want you to design new algorithms, understand research papers. So all those things is possible only when you understand the basics, the maths part very I mean in a bit of depth, right? So other than that, you should learn programming. I mean, that is something which is essential for any engineering student, I would say. So pick up your programming language. So in case of AIML, you can better choose Python and start working. Try to read not only books but also research papers. You may find it a bit difficult initially, but reading research paper is very essential in, at least in AI field, because there is a lot of work going on. I mean, the world of AI is changing very fast. So uh, even if you don't understand the whole paper word by word, no problem. At least try to skim through the paper. Try to get the overall gist of the paper, what exactly they are talking about. Quite important, I feel. Better be stay informed about what is going around. Try to read blogs. I mean, you can even follow social media experts from these AIML field. Try out your hands-on experience on practical projects, and stay curious. Continue your learning. I think these are some of the aspects which is important for any beginner, or whether you are already working in this field.
Thank you for the session. Let's move forward to the questions by the audience.
Okay, so I have three questions to ask you.
Three, okay.
Yes. My
One, first one, yeah.
So, my first question is about artificial general intelligence. So, as of today, we are focusing on creating an artificial general intelligence. But my question is like, what if it comes to happen? It becomes sentient. But like conscious. So if the program is conscious, it would almost be like having a human being. So and if we try to use it as a tool, wouldn't it be problematic? So instead, why don't we focus on creating AI tools which are like have been catered for performing certain specific tasks rather than focusing on actual general intelligence?
Yeah, so very good question, in fact. So, right now, there's a big area of machine learning. Which, I mean, there are a lot of researchers which are working on AI ethics. Yeah, so AI ethics and uh, so I mean that relates very much to the question you have asked. In fact, as I told you, I mean right now AI itself is a not very mature field. It is right now evolving in terms of consciousness. I mean still very far. I mean right now that AI has not yet reached to that level, but it is important that even government agencies, and in fact there are a lot of government agencies which are now planning into framing a good set of rules to control or regulate these AI ethics. There are a lot of research also going on this in this direction. So yeah, those things will also come in place. But right now, I feel this kind of achievement is quite far.
Okay. And my second question is, like, even though we are right now still continuing to pursue this goal, but what if in future it may come to pass that we may discover that it is not at all possible to like program consciousness? Like, what if it turns out that consciousness is actually a kind of like inherent fundamental quality of the universe itself? Like, for example, you may able to simulate a magnetic field, its behavior, but you cannot actually program a magnetic field into an object. So similarly, what if it's not at all possible to program consciousness? So how will that turn out for the future of AI? How can it?
No, how will that?
How will that look forward? How will that turn out for the future of AI? Like then, what will be the further possibilities if it is impossible to program consciousness or create a
Well, I think we are moving into a very. The question you asked is also very related to the previous question. So I don't think it is really possible in very near future. I mean, uh, and that will not stop AI to develop. AI is a much broader thing. I mean, consciousness is just a small part. Obviously, it's a very complicated part to achieve, but that is not the ultimate goal. So I feel there are many other fields also which AI will keep progressing, and presently it's still in a very initial stage. So I don't think that will be a limitation. I mean, even if you don't achieve that consciousness part, there's still a lot to explore.
Okay. And my third question is, since you are a scientist yourself, so in today's time, as like you already know, the technology in each and every field is growing at an exponential rate. So how do you face the challenge? Like if you came up with an idea and you tested it, but then you find out that it has already been developed a few years ago. So how do you face that challenge and keep on innovating something new? Which has
Can you repeat your question? I'm kind of missing you in between.
so, as excuse me, in today's time, we know that technology in each and every field is developing at an exponential rate. So, how do you face the challenge like you came up with an innovative idea, but then you found out that it has already been done quite a few years before. So, how do we keep up with this kind of rate of at which technology is going, and how do you keep up developing new and new innovations which have never been done before?
See, yeah. So when you say technology is going at a very rapid pace or exponential rate, it's true for AI and many other fields which we do on ground. But if you see the space area, the space it's not so easy to implement everything because space is very critical. It challenges you. It's not very friendly, so you cannot implement any technology in space just like that. So there is always a budget constraint, right? So I mean, being in the third world, I mean, being in a developing country like India, you always have this budget constraint. So it's better not to look on your neighbors. I mean, not to look on other people what they are doing, but it's important to stick to our goals, what we have not done it, and what we are planning to do ahead. Okay, for example, NASA is way ahead of in quite many things for quite many robotic applications and all, but still the imaging systems which is already on moon, we are the best one because we have even 4 times better resolution of them. So it's important not to look on others what they are doing, but to concentrate on what is our requirement, what is our way ahead. So it's always better to look our preferences, look our strength, and then take the next step forward. And in space, you cannot take a huge step at any I mean, point of time. You always have to progress one by one, which is very important. Otherwise, you will end up losing a lot of money. Okay, and that's why not many startup and not many people attempt to take these I mean, attempt to spend a lot in space in one go. I mean, there is always a very gradual increase of technology in space, unless you have a lot of money.
Okay, thank you.
Now, anyone from the audience have any other questions?
So my question about is a bit related to the Chandrayaan 3. As we know that Chandrayaan will landed on the south pole, and it is very difficult to have a soft landing over there. So as per my knowledge, I know that when it reaches to the height of 1 kilometer above the lunar surface, it tries to search for an space where there are no craters nearby, and it can have safe and soft landing. So it takes a decision by itself that where to land and how to land. So is there any uh, technical support by AI in maneuvering that paths or anything related to it currently?
Okay, yeah. So without disclosing much, I would say yes. Definitely, there is a lot of possibility of AI there. If you see the area which we defined prior to launch, it was a 2 kilometer by 1 kilometer area, and so that was one area which we decided will land because there are not many craters at that point at that place. Uh, so once we reach to our hovering phase. And finally, when we landed in the 1 kilometer direction, we were just away by around 200 250 meters, and in the 2 kilometer direction, we were away by I think 400 to 450 meters. And yeah, the identification of the area or the place of safe landing, there's a lot of role of AI there. I mean, good that you pointed out. Yeah.
Thank you, Bhaiya, for sharing your experience and valuable inputs. Now, handing over to you.
Before we conclude, I'd like to extend a heartfelt gratitude to our distinguished.
सर एक्चुअली मेरा क्वेश्चन है फिजिक्स में जिन बच्चों को ज़्यादा इंटरेस्ट होता है फर्दर स्टडी के लिए क्या एक्स्ट्रा करना होता है से मतलब काफ़ी कुछ अच्छा करके कर सके फिजिक्स के
Can you be a bit louder? I'm not able to hear you.
एक्चुअली मैं ये पूछना चाहता हूँ कि बच्चों को फिजिक्स में जैसे मैं फिजिक्स में ज़्यादा इंटरेस्ट है तो मतलब इस इंटरेस्ट को और बढ़ाने के लिए और फिजिक्स के फील्ड में कुछ अच्छा करना है इसके लिए क्या कुछ करना होगा फ्यूचर प्लान
Yeah. So actually, the area of physics changes quite a lot after your 12th, right? So once you if you are really interested to work only in physics, I think research is a good direction to move forward. Uh, Obviously, in ISRO, we are working in a math physics department, so where we work mainly on the astrodynamics part. But if you really want to do good in theoretical physics, uh, I will suggest you to better try for abroad universities because there are a lot of research going on in theoretical physics. And obviously, if you are interested in physics, maths, and programming, that will go hand in hand. So, I mean, don't hesitate to expertise on maths and programming both. I think, and yeah, a good way to move next step forward is to apply for research, because physics research is, I mean, really very exciting.
Anyone else from the audience? So, before we conclude, I'd like to extend a heartfelt gratitude to our distinguished guests for gracing us with their presence and sharing their knowledge of machine learning and its intersection with space exploration. We are truly honored to have had you with us today. Thank you once again for your time and expertise.
Thank you so much for inviting me. I mean, seeing all the students sitting at one place for about 50 minutes is kind of very surprising for me. But yeah, I mean, a big thank you for everyone for remaining so calm and composed for the whole duration. And thank you, Shaurya, for making this possible.
Thank you, Bhaiya, for coming and sharing your invaluable experience. See you soon.
Thank you. See you. Bye.
Special thanks to our sponsors, Scholar Personal Tutors, and Pramukh Guru Input.
Okay, I'll disconnect.
Yes. Okay, so thank you to our sponsors for making this possible. Pramukh Guru Infotech and Scholars Personal Tutor, as discussed by Piyush Bhaiya. If you want to learn AI and ML personally, you don't rely on YouTube courses. We are providing you with a one-on-one from IIT graduate teacher who will teach you machine learning and AI. So thank you.